Sharks. They're older than dinosaurs, older than Mount Everest, even older than trees. Honestly, there's not many things on this planet that are older than sharks.
Unless you count my mom, that is.
Is that how this is going to go today?
Yes.
Okay. Well, sharks first appeared about 450 million years ago and are still going strong, surviving, nay, thriving through 5 different mass extinction events. And they may have the right stuff to make it through a 6th.
If you want to learn how to adapt, survive, and thrive under the worst possible circumstances for the longest time, let sharks be your guide.
Honestly, that just sounds dead useful. So today, as we comb the Carolina beaches in search of sharks, we're going to tell you the story of what made them the most super surviving of all super predators through the ages.
Let's go! Now, sharks are one of the coolest ocean life. Can we all agree on that? Can we? So, here are a few sharks that live in the South Carolina and North Carolina region. We got great white, we got blacktip, we got lemon, we got hammerhead, we got my dog, we got bull, and we got many others. And know what's special about all these sharks? They all have in common. They're descendants from sharks that survived multiple mass extinctions.
Not a shark. I just named some of the 500 species of sharks that are swimming in our oceans today.
The story of sharks began 450 million years ago during the late Ordovician period.
Traces of their ancestors have been found in the fossil record as scales, but no teeth, which hints at the possibility of a toothless origin for these predators. Yet the debate among scientists persists as to whether these earliest of creatures were actually sharks.
A major problem for paleontologists studying ancient sharks is that there isn't much fossil record to help us understand their history.
It's true, shark skeletons are made of cartilage, which doesn't fossilize well. So everything we know about these early sharks comes from the remnants of these hard tooth-like scales that used to cover their bodies.
Whatever these creatures look like, even in these early forms, they survived the first end Ordovician extinction.
Now, this was absolutely an early win for the species because this was by some measures the second largest extinction event on our planet, exterminating some 86% of species on Earth. So, strong start, shark ancestors.
And this is shark survival lesson number 1. Hang on when things get rough and roll with it. Keep evolving.
Evolution moves on, and the earliest hints of shark-like teeth start to emerge in the early Devonian, about 410 million years ago.
Changes in early sharks are embodied by an ancient philosopher named Doliodus Problematicus. Oh, did I say philosopher? I meant ancient fish named Doliodus Problematicus. You can see how I get mixed up.
Doliodus Problematicus. They're actually a precursor to what we recognize as sharks today, and not an ancient Greek philosopher, although their name awesomely means problematic deceiver. Now, while there are many fun ways we could imagine them earning this name, they earned it because scientists just couldn't decide how to classify this creature. And they changed the classification kind of back and forth from shark to ankythodian, which was a kind of fish with a jaw and at least some teeth, but it probably didn't look much like a modern shark.
So then, when did sharks take their classic, creepy, torpedo shape we think of them being today?
Well, by the middle of the Devonian period, approximately 380 million years ago, sharks resembling eels started to surface.
Among them, Claudosolaki stands out as one of the first true shark-like forms.
Torpedo shape, forked tail, dorsal fins primed for predation.
But it's also possible they were chimera and not actually true sharks, so...
But hold on, because we are about to enter the second mass extinction that happened around 360 million years ago in the late Devonian. Now, this one killed off about 75% of species on Earth, including many branches of fish relatives that once swam those oceans with those early sharks.
Sharks not only survived the extinction, they dominated. They got rid of all the fish competition and took over.
You might say they were now the big fish in the Panthalacia.
Anyways, this is shark survival lesson number 2. Look for opportunities to thrive.
The Carboniferous period ushered in the golden era of sharks and some serious shark dominance. This era birthed a bizarre array of shark relatives and evolutionary experiments,
including Stephacanthus, with its curious anvil-shaped dorsal fin, and Helicoprion, boasting a buzzsaw-like jaw, a personal favorite.
And this brings us to the big one, not the big shark. That one's coming later.
No, we mean the end permanent extinction, the Great Dying, so far the largest mass extinction our planet has faced.
Life barely held on during this one, with 96% of species going extinct. But shark lineages endured through this and a 4th mass extinction at the end of the Triassic, continuing to evolve into the Jurassic into the forms and shapes and groups that we see today.
like the hexancoformes. Yeah, hexancoformes, that's a real word. Or sickle sharks that emerged during the early Jurassic.
This is the oldest group of sharks alive today, and the Jurassic also saw them swimming the seas, followed soon after by most other modern shark groups.
At this point, sharks are developing more of the abilities we know about them having today. They swim faster, can eat bigger prey, with their flexible, protruding jaws.
By the time we get to the start of the Cretaceous, things are going pretty well for sharks. Honestly, they're common, they're varied, they're swimming the seas, life is pretty good for them. Until quite suddenly, things are exceptionally not good.
Not good at all. We're talking about the end Cretaceous, probably asteroid-driven extinction here, people.
The time when the mighty and beautiful non-avian dinosaurs who ruled this planet for nearly 165 million years, along with a whole mess of other species, went extinct. The environmental collapse that followed the end Cretaceous asteroid event killed off an estimated 59% of shark species.
So what helped the others survive?
Recent research using a large database of fossils from this period suggests some key factors to their survival, including being a dietary generalist, so not being a picky eater. Geographic location, with sharks who inhabited larger ranges, deeper water, or higher latitudes more likely to survive, and being a relatively newer species.
With the older species more likely to die out. As for the flexible eater thing, missus. And this is shark survival lesson number 3. Don't take up too many resources and be flexible.
Once again, after the end Cretaceous event, sharks bounced back, evolving throughout the Paleogene into some of the largest forms yet.
This is when the ancestor to Megalodon, another personal favorite, Octopus obliquus, first appeared.
Their descendant, Ototus megalodon, was one of the most powerful predators to ever live and certainly one of the largest sharks to ever live, likely 15 to 18 meters in length.
But now if you're wondering why all your science books say Carcharodon megalodon and not Ototus megalodon, it's because scientists recently changed it to Ototus megalodon because they realized that megalodon isn't so closely related to the great white at all. You remember Anne Bonny, right? And if you don't, then watch our previous video. It's pretty good and it explains about Anne Bonny.
Megalodon and great white's ancestors, who evolved around the Middle Eocene, were actually competitors.
And we know which one won.
But why did the smaller of the two predators survive until today? Well, most likely it was because it could adapt to the changing climate, and Megalodon just couldn't.
How did sharks withstand 5 mass extinctions, all of which had different causes and impacts?
Well, while their resilience plays a part, it's their astonishing diversity and adaptability that truly define their survival. By exploiting various ecological niches, from the depths of the ocean to rivers, and also by not being picky eaters and consuming a wide range of prey, their flexibility and adaptability means they can pivot and persist as oceanic overlords, shaping the seas for eons.
Those who adapt, like the sharks, survive.